Next, I want to show you a little bit about how to load data into R. So if someone gives you a file which already has data in it, how to load it into R, and a little bit about how to summarize that data. So in particular, we'll be talking about summary statistics. And mostly about the what we call the 5-number summary in class. So the first thing is when you're going to load data, again, I encourage you to make a script. So if you don't have a script yet, hit new file, R script, and it'll pop one up. Go ahead and name it. So I called my file load data and summarize. Okay, so once you have a file loaded, then we're going to set what's called the working directory. And so wherever you want to work on your project, so for example, I'm working in this scripts folder on my computer. And in here, I have this penguins data. Okay, and this is the data that I'm interested in working in. You'll notice that this load data and summarize, the same R file that I'm working with is in the same directory as the data that I want to load. Okay, it's really, really key that we're in that same directory. And just to be super cautious, we're going to do something called setting our working directory in R. Okay, so if you want to get what your current working directory is, you can type into R's console get working directory, open close parentheses. And what it'll spit out for you is it'll spit out a string. Okay, and so this string will tell you kind of the directory at which you are working. So this is where it's expecting to find files. It's expecting, this is kind of this part of your computer that you're working on. And the idea is that we would like this to be the exact same location as where my data is. Now you'll see, right? You'll see that kind of just by, happen to be that my working directory is already in the same place where my data is. So it's already in Stat 145, R tutorial scripts, right? It's already in that location. And again, that is where my data is. So I'm happy about that. Now, if this wasn't matching up, if this was different, okay, then what you want to do up here is you want to set your working directory, okay, in the beginning of your script. And what you want to set your working directory to is wherever your data is. So again, my data is in this directory. So on Windows computers, you can click on this directory and copy it. I'm sure there's something similar in Mac. And then what I'm going to do is I'm just going to make sure that my arrow, my slashes are pointed consistent with what R wants. So you can see R wants my slashes in this sort of forward direction on Windows. So I will go ahead and switch these slashes to be in that forward direction. So again, the idea is that I'm setting the working directory to be wherever my data is. Right, so your current working directory might be something different, okay, but you want to set your working directory to be where your data is. And so if we go ahead and run that, so again, I'm using Control Enter, right? Enter won't do it. So I hit Control Enter. It will go ahead and tell me, okay, we've set the working directory to this location, and that's important so that I can read in my data. So how do you read in your data? So I'm going to put a comment here to say load in. This is penguins data. So this is my penguins data. You might have a different data set. And the way that you do this is you'll say penguins data or whatever you want to name your data. So I like calling it basically what it was, right? Penguins data, but I'm using an underscore because remember, it's very critical that you don't actually use spaces in your variable names. So penguins data. And then the way we do this is so we tell R that we want to read a CSV. And so you'll see it's already suggesting read CSV, and it says you need to give it a file. Okay. So if I open and close my parentheses, the file that I want to provide, I look at my file. It's called penguins data, right? Penguins data. So I want to load penguins data. And if you try to run that, it's going to give you an error, okay? Because it says, oh, I cannot open this file because no file exists, right? No such file or directory. Okay, so if you just put the name here, you're going to get an error. You have to put the extension that it's a .csv file there, and then it will load it. So I just reran that line, and now it loaded it. So if we look here, use this little drop down, it says we've got penguins data. We've got 333 observations with 7 variables. And they are species, island, Kalman length, Kalman depth, flipper length, body mass, and sex. And you can see that it's assigned variable types. So species are either Adele, there's other kinds of penguins. So it's given them characters, characters for the different penguin types. Islands are Torgerson. There's other kinds of islands. Again, that's a character. But then the lengths and depths of the Kalman are numbers. The flipper lengths are whole numbers, so they've called them integers, but that's still, again, a kind of number. And then the body mass, okay, so that's measured in grams, and that is also an integer. And then we have the sex. So if the penguin is a male or a female, is recorded as a string. And if you double click on this, you can actually open up and you can see the data set. So you can see the rows and the various columns, and you can see, Bisco is another island besides Torgerson, and there's Dream Island as well. And there's, I keep scrolling, there's chinstrap species, right? So we can see all of that here. So I'll go ahead and close that off. So one sort of basic thing that you might be interested in doing is making some sort of descriptive statistics. So let's do some basic descriptive statistics. And let's do it for a quantitative variable. Okay, so let's pick one of these quantitative variables. Let's do flipper length. Okay, we'll talk about the flipper lengths. You might be interested in the average or the mean flipper length. To get the mean flipper length, what you'll do is you'll say mean, and then you'll say, well, my flipper lengths live inside my penguins data. And then you put a $sign and you specify that you want to do flipper length. So if I run that, you'll see that it tells me that the average flipper length is 200.967. In this case would be millimeters. Notice that if I try to do the mean of something that is not a quantitative variable, so maybe mean of penguins data, and I try and do it of sex, right? It says the argument's not numeric, right? So it doesn't like it, and that makes sense, right? Should not be working, right? And if I just do mean of, and then let's say flipper length, it won't know what flipper length is, right? I have to give it this sort of flipper length with a $sign inside of penguins data. And you could also get the median for penguins data, and you could do flipper length. You could also get the median. So the median is 197 millimeters. And you could also do our sort of other quantities. So you could figure out what the range is. So if you want to figure out the range of the flipper lengths, we can do that. And so what range is going to do, it's going to give you the smallest flipper length and the largest flipper length. So this is going to give you 172 is the minimum flipper length, and 231 is the largest. You can figure out the interquartile range. Again, you can just type your data and you can say flipper length 23. Okay, so that's the number of millimeters that separate the 75th percentile from the 25th percentile. And then if you want to get the quantile values in particular, you could type quantile penguins data. Okay, and then we have to specify for quantile, we have to specify for which quantiles we want. Because remember, you might be interested in the 25th percentile, the 50th percentile, the 75th percentile. And so the way you tell R which percentiles you want is you say probs equals C. And then what I'm going to do is I'm going to provide it a vector of percentiles that I'm interested in. So I'm interested in the 25th, the 50th, and the 75th, but you might be interested in other values. And so if I run that, you'll see that it will tell me the 25th percentile is 190, the 50th percentile is 197, and the 75th percentile is 213. And, so if you're wondering, how did I know what went where in that function? If you're wondering how would I ever know, to include this probs or whatever, you can type quantile with a question mark in front of it and R, and it'll bring over for you a little menu that tells you what it does. So it produces the sample quantiles corresponding to the given probabilities. And so you can see that you provide X, which for us, this is representative of X. That's a numeric vector whose sample quantiles are wanted. So we want the quantiles from that vector. The second thing you should include, okay, is probs. And probs is a numeric vector of probabilities between 0 and 1. So these are the actual values we're interested in. Okay. And then everything else that's after here, right? You don't have to include all these. Okay. So these are more optional things you could include. Right? Anything that doesn't have one of these equal signs, you technically don't have to include. So we could have even left off probs. Okay. And so we just decided to specify it because we wanted to say which specific probabilities we wanted. If we didn't do that, it would have given us the 0th percentile or the smallest value, the 100th percentile or the largest value, and the 25th percentile. Okay, so that's how you get some basic descriptive statistics. Another thing you could do is talk about categorical variables. So if you want to get some basic descriptive statistics for a categorical variable, how would you do that? So in this case, the idea is that you want to pick out a categorical variable, and I spelled that wrong. So we might be interested, let's do the species. So again, R quickly loads that. And so if you run that, right, it's going to spit out a whole long vector of Chinstrap, Gentoo, Adelaide. It's just spitting out the all of the various species that you have. And you might be interested in just trying to figure out, how many individual penguins do I have in each category? So if you hit table, put table around this and run it, it'll say I have 146 Adelaide penguins, 68 Chinstrap penguins, and 119 Gentoo penguins. And you might want to know what those are as proportions. So if you say prop.table and do that around your table, so we'll do the species again, it'll say about 43% of our penguins are Adelaide, about 20% of them are Chinstrap, and about 36% are Gentoo. So it'll automatically do that for you. So you don't have to, go through here and count each one. And there's even faster ways to try to do some of this stuff. So, for example, notice how our species, island, and sex were labeled as strings, or characters. And so the idea is that R doesn't think about them necessarily as separate levels or factors, is what R's would call it. And so one thing you can do is you can turn the characters into factors. So if we turn our characters into factors, it's going to do something special for us where we'll be able to do some of this even faster. Okay, so we know that, for example, penguins data, we know that the species there, that really is a categorical variable. So we can say that we want to assign, we want to assign the species, we want to assign the species as what the species were before, but I want to apply a factor to it. And what that's going to do is notice that this changes species to a factor with 3 levels. So now the idea is that you've got Adelaide, Chinstrap, and Gentoo penguins as 3 different factors or 3 different levels. And we can do the same thing for the other categorical variables. So we can do this for island, doing this for island, and we can again do this for sex was the last categorical variable. And you'll see as I run those 3 lines, all of these, which used to be characters, have been turned into factors. So you might be wondering, okay, great, why would you want to do that, right? The reason you would want to do that is because now if you type just summary and you want a summary of your entire data set, what it will do is, so again, I'm not specifying I want a summary of a particular column, I'm just leaving it for the whole data set, it will know kind of what statistics we're interested in. So it knows to count the number of Adélie, Chinstrap, and Gentoo penguins, the number of penguins on each island, Biscoe, Dream, and Torgerson. And then at the same time, it can quickly provide you the minimum, 25th percentile or first quartile, median, mean, third quartile, and maximum for all of your quantitative variables, right? So right there in all of our quantitative variables. And then again, we have another categorical variable. So it's counting the number of female and male penguins. And it's doing all of that very quick for us instead of us having to run all these lines. So turning your characters into factors can actually speed this up quite a bit. But that's how you load in data. So I will go ahead and save this. But this is how you, you can go up here and hit the save button. This is how you load in data and how you can get some sort of quick summary statistics about your various columns.